everybody, and welcome back to another episode of Meg's How-To Videos. For today, we're going to go over how to make a multi-purpose enclosure for your 3D printer.
Are you ready for this? Pass that back to the gang, the boys. Let's go, lose control. Slip and slide on the dance floor. Let's go, lose control. Slip and slide on the dance floor. Let's go, lose control. Slip and slide on the dance floor. Let's go, lose control. Slip and slide on the dance floor.
Now, before every build, make sure you take some time to draw out some blueprints. Here, I'm going to throw mine up on the screen. Feel free to pause the video or take a screenshot so you have something to reference. Once you have collected all the materials, it is now time to measure and cut each piece to its required length. Now that everything has been cut, start off by screwing together the two 2x4s that are 24 inches long to two that are 19 inches long, with the 24-inch ones on the outside and the 19-inch ones on the inside. This will make a rectangle base that measures 22 inches long by 24 inches wide. Next, take the bottom plywood piece you cut to 22 by 24 inches and screw it to the rectangle base. Using some 90-degree mounts, attach each of the four 24-inch long 2x2s to the four corners of the base. For this next step, attach the top cross members, which consist of two 21-inch long 2x2s and two 19-inch long 2x6s. If you don't have any 2x6s, don't worry, you can do what I did and just attach some 2x2s to some 2x4s. Securely fasten down the pieces of plywood that will cover the top and back of the frame. Then, give it a few coats of paint. Once the paint has finished drying, it's time to move on to the electrical portion. First, start with the power outlet. Here I used a 3-prong IEC AC receptacle outlet and mounted it into the back bottom left corner. Using my 3D printer, I was able to make a box for the control switches. Here I used 4 on and off rocker switches, with the black switch on the left acting as a master switch and the other 3 controlling different wall outlets. When installing the switches, trace an outline of the box 4 inches from the left and 1¼ inches from the bottom of the base. With a chisel, cut out a hole just deep enough for the box to be flush with the face of the 2x4. Drill a hole large enough to feed the wires through, then screw the box in place. Directly across from the switches, next to the power outlet, drill a hole into the platform large enough for the wires to fit through. This is where the wall outlet box will be mounted. Since it was hard to film how I had wired everything together, I figured it would be easier to just draw up a wire diagram. Here on the left, you can see how I wired the power outlet to the wall outlet box, and on the right, how each switch is individually wired to the outlets. With the outlets installed, let's move on to installing the LED lights. Here I installed some multicolored programmable lights to my 3D printer. I was able to attach the LED strip by printing out some mounting brackets that attach to the frame. Next, I installed some solid white lights to the inside of the enclosure and ran them along the left, front, and right sides, leaving the back exposed. Most LED strips are rated at 12 volts, 1.5 amps, so make sure to purchase a set that supplies its own power cable. Now that the lights are installed, the next step is to install the thermostat. Here I purchased an Inkbird ITC 1000 series digital thermostat. To install the thermostat, measure 2.5 inches away from the switches and 1 3/4 inches from the bottom of the 2x4. Trace an outline of the thermostat, then cut out a hole to mount the device. On the inside front right corner, drill a 1/4 inch hole to run the thermostat sensor through the base. Attach the sensor wire to the right side 2x2 support beam and mount the sensor in the center of the 2x2 above the front opening. With the sensor installed, we can move on to installing the cooling fans. I will be installing two 12-volt 500 milliamp fans I pulled out of an old computer. Since the thermostat uses 110 volts, I need to wire the fans to a power adapter. Lucky for me, I found one in my stash of wires that has an output rating close enough to what both fans are rated at. Now before you wire the fans together, make sure to drill a 1/4 inch hole into the front left corner of the base. This will allow you an opening to run the connecting wires to both top and bottom fans. Next, trace out a square that is a 1/2 inch smaller than the fan, centered to the base. Once cut, this will allow you enough overhang to mount the fan. On the other side of the base, attach a fan guard. This will help prevent foreign objects from getting lodged into the fan. When mounting the top fan, again, trace out a square that is a 1/2 inch smaller than the fan, centered to the top. Cut out the square and attach a fan guard. Underneath, line up the fan with the opening and screw it in place. Wire the two fans together and mount the connecting wire along the left side 2x2 beam. Now, when it comes to the heating element, I purchased a Mini Mainstays personal ceramic heater. And what I like about it, besides that it comes in a variety of colors, is that it is small and portable, so it's not going to take up a lot of room inside the enclosure. Also, it is super cheap and affordable. It cost me about 10 bucks at Walmart. Before you install the heater, make sure to hot glue the safety switch down in the open position. Next, in the back right corner, cut out a square that measures 3x3 inches. Then, with 3 screws, attach the heater to the back panel from behind. Here is an image of what the heater looks like from the inside, so you know where to place those screws so they don't hit something important. Once the heater is fastened down, cut a notch into the back 2x4 of the base to mount and run the power cable through. Since again, it was hard to film how everything was wired together, I decided to draw up another wire diagram. Here you can see on the left, I supplied you with a copy of the manufacturer's wire diagram, and on the right, I put together a more visual diagram on how I wired each item to the thermostat. Let's move on to the filament spool hanger. First, cut out a metal rod to 20.5 inches in length. Using some rubber covers, cap off both ends. Fasten down a set of hanger rod wall mounts adjacent from one another, 5 inches from the back and flush with the bottom of each 2x6. On the back panel, attach 14 wire staples to help guide the filament. To reduce friction and drag on the filament, we need to install some pulleys. Attach a 90-degree angle bracket to a piece of 1/4 inch plywood. Then, screw a pulley to the outside part of the bracket. Mount the bracket above the heater and attach another pulley to the other side. Since this enclosure is somewhat large, I decided to add some handles to the sides to make it easier to carry. Next, let's cut acrylic for the doors. If you don't know how to cut acrylic, feel free to check out one of my other how-to videos. You should find a link in the upper corner or in the description below. Here I printed out a total of 9 hinges, 3 for each door. Place one hinge centered to the acrylic and the other 2 inches in from either side. With a 3/16 inch drill bit, drill out the holes and mount the hinges using some short machine screws and nuts. I didn't have any that were short enough, so I decided to cut what I did have to the proper length. Next, to mount the handles, use the same drill bit and drill 2 holes 2 inches in from the opposite side that has the hinges. Here I'll be using 2 8-inch T-handles for the side doors and one 12-inch T-handle for the front door. Once both hinges and handles are attached to the doors, use some 3/4 inch sheet metal or drywall screws to fasten the doors to the frame. When attaching the door to the frame, you may need to put some washers behind the screws to act as spacers to allow the doors to close properly. Since I'm using 1/8 inch acrylic for the doors, I will need to install 2 magnets to the inside of each door frame. One magnet will be mounted in the top corner located above the handle, while the other will be mounted in the bottom corner underneath the handle. Next, line up the metal plates with the magnets, and while using some sort of epoxy, glue the plates to the inside of each door. As a bonus, to help the enclosure retain heat easier and reduce noise, I installed some weather stripping along the inside of each door frame. Now, before we get to the finishing touches on this project, please give me a few seconds to talk about how you can possibly save money on this project and future projects of your choice. No, this isn't a sponsored video. I'm not going to try to advertise or sell you something. Instead, I'm going to be talking about a world crisis that's going on, which is waste. All around the world, landfills are filling up, and that's because people nowadays discard and throw out items for the most ridiculous reasons. Like, they don't have room to store it, they no longer want it, it stopped working. Well, if no one wants it and no one's going to fix it, you might as well salvage parts off of it. You would be amazed on how much money you can save by doing this. For example, here's a list of all the discarded items I salvaged and used just on this project alone. Now, I based all my prices off the lowest cost found online, so keep it in mind, I might have saved myself even more money than if I was to purchase these items at a convenience store. Hopefully by seeing this will help encourage you to go out there, salvage parts off of discarded items, save yourself money, and help reduce waste. Another feature I added to this enclosure are the SD card and USB-B cable ports. When installing these cables, trace an outline where you would like to mount each port. Then, cut out both holes. This USB-B port came with some screw mounts attached to each side, so I just screwed it in place. To mount the SD card reader, you can otherwise glue it in place or install some sort of back support to prevent it from being pushed through. Drill/cut out a small hole into the base plate to run the cables through to your 3D printer. Once the cables are installed, I then laid down some 1/4 inch thick foam padding to cover the base, and also glued some 2 inch thick foam pieces to both sides and back panel. By installing this foam, this will help further aid in reducing noise. Now that everything has been installed in the base, I made a bottom cover to help conceal the internal electrical components. Here I cut a piece of 1/4 inch plywood to 24 by 22 inches and added a metal grate to an opening in the middle to help let air in for the bottom fan. Next, I 3D printed a tool holder that was designed to hold all the tools that came with my 3D printer. I then fastened the tool holder to the bottom of the top left 2x6, 3 inches away from the front door. Last, I built a stand out of the 2x2s and 2x4s I had left over. The stand measures 24 by 22 by 30 inches. I also installed some adjustable feet to each leg. This allows me to adjust each leg's height to make sure the enclosure stays level. there you have it. Now you know how to make a multi-purpose enclosure for your 3D printer. If you have any ideas for add-ons or upgrades to this enclosure, please leave them in the comments below. I'd love to know your thoughts. Also, I hope I encouraged you guys to go out there and salvage parts from discarded items to help aid you in future projects. Lastly, if you enjoyed this video, please leave a like and subscribe to my channel to see more how-to videos. It really helps me out. But until next time, God bless and good luck.